A new international study led by astrophysicist Eric Agel from the University of Washington and involving scientists from the University of Liege has measured the densities of the 7 Earth-sized planets around TRAPPIST-1 with extreme precision. Scientists now know more about the densities of these planets than any of the other planets outside our solar system, and this provides an important clue as to their compositions. 3 of the system's outer 4 planets lie in the habitable zone, the area around the parent star where a rocky planet is most likely to have liquid water. Although these planets are similar in size to Earth, they orbit much closer to their host star, an ultra-cool red dwarf called TRAPPIST-1 that is only slightly larger, though much more massive, than Jupiter. The TRAPPIST-1 system is located about 40 light-years from Earth in the constellation Aquarius. Both the TRAPPIST-1 system and our solar system lie on the Orion spur between the Perseus and Sagittarius arms of our galaxy. The new study indicates that the 7 planets are remarkably similar in composition and contain roughly the same proportion of materials such as iron, oxygen, magnesium, and silicon that make up our planet. The study found that the planets are all around 8% less dense than Earth. The authors of the study proposed 3 hypotheses to explain why the planets are less dense than Earth. One possibility is that, like Mars, the planets have a rocky surface covered in rust, which is iron oxide. Only unlike Mars, which has a core of unoxidized iron, the iron oxide on these planets would be mixed with other elements all the way to the core of the planets, and the core itself may be oxidized iron. A second possibility is that the planets have a rocky surface with an iron-rich core that is smaller than Earth's. A third possibility is that the planets have a deep ocean layer on their surface and a larger iron-rich core. The third hypothesis is possible for only the outer 4 planets in the TRAPPIST-1 system. If it is correct, then water would account for 5% of their total mass, compared to 1% for Earth. The inner 3 planets are too close to their star for liquid water to exist on their surfaces. However, they could retain water-heavy clouds if they had a dense atmosphere like that of Venus.